Okay, starting from today, we talk about inheritance. It's a very big topic, but I think it's really worth learning. We'll start with something a little bit light today, and then starting from next time, we're going to build up from today. Okay? We're going to use this particular example throughout the next few lectures. So I assume that you have reasonably familiarized yourself with this example over here. Okay? Let me just highlight several things that you want to pay attention to. Okay? Very quickly. First of all, what we are trying to define is, that's kind of the principle we talked about before. You want to identify the critical nouns and verbs. Okay, that's kind of the principle. But now, eventually what we want is a student management system where we're going to have maybe either one array or several arrays of students. And student can be different types. Okay, we got two types of students. We got resident students, and also we got non-resident students. And we're going to see that somehow we want to have a way to distinguish between these two kinds of students. We want to have a way. And then for every student, you got a name, you got the registered courses, and you can definitely use the programming pattern that we talked about, use the integer, counter, and also the array. And also every student, doesn't matter resident or non-residents, they can register for some course, like add course. You can also calculate the tuition of the students. We'll see some concrete example in just a moment. Let's say if you have registered for 5 courses, you got to add up all the fee for the courses and calculate the tuition. Very simple method to calculate. A little bit more detail. For non-resident students, we charge them a little bit less. So we have something called discount rate. For example, 0.75. So they can get cheaper tuition, let's say. And also we got the second kind of student called resident students, and we charge them a little bit more because they live on campus. And that way, we maybe 1.25, for example. So that will be a little bit higher for the tuition. But the base amount is going to be calculated in the same way. Okay? So that's kind of the example we're going to focus on. Any questions? Okay? Last Wednesday, this is how we ended up with. I asked you guys to see, let's not worry about inheritance just for a moment. How would you design classes for this particular problem over here? That's my question, right? And you guys collectively told me that what you would get is something like this. I'm going to present it, okay? Before we ever reach the inheritance, I'm going to show you 2 alternative design without the inheritance. And for you guys, I would definitely go over for each design without inheritance and criticize on that, so you would know why we really want inheritance. You can really eliminate all the drawbacks that we're going to talk about. Version number 1 without the inheritance. Okay, so this one is not on the slides, but version 2 is on the slides. Okay, version 1. I'll go over the code. The code is very simple. Don't be terrified. Very simple. Okay, let me just go over the code very quickly with you. So we have only a single class for students. Let's forget about the student management system for the moment. Okay, let's not worry about it just for now. Let's worry about how we can distinguish between the 2 kinds of students, either resident students or non-resident students. Let's say. So we got a single student class, and also we got a course array, we got integer counter, very standard. The one you want to pay attention to is this particular attribute here, kind, of type integer, which means, let's say, when the kind is actually happen to be 1, that means the current student we are talking about is resident students. If it is 2, it's going to be non-resident students, let's say, okay, either 1 or 2. Let's make that assumption. And then, since we only got a single class, we're going to somehow put the premium rate and discount rate all together, right, in the same class. That means if the kind is equal to 1 for resident students, in that case, we have to apply the premium rates. If the kind is equal to 2, we're going to apply the discount rate to calculate the tuition, right? And then also, if you want to initialize the student objects, you're going to pass the integer kind, either 1 or 2, let's say. Okay, accordingly, I want you to look at 2 methods that you may want to define. Of course, realistically, you might want to define many more methods, depending on what the kind of student we are talking about. The first method to look at would be, let's say, get tuition. For get tuition, we simply started with some base amount, simply start with 0, and then we'll simply go over the array and then simply add up the fee together. Okay, it's very straightforward. And now, here's the thing. Okay, look at this. We are basically saying if the kind of student is equal to 1, right? Remember this attribute over here? If that's equal to 1, you're going to apply for premium rates, right? If the kind is actually equal to 2, then we apply the discount rate. Any question about get tuition so far? Okay, very easy. So now, This particular if statement structure is going to be very common to be used because now we have different kinds of students. So that means every time, most likely every method you want to define on the student objects, before you can do any appropriate actions, you have to see what kind of student am I trying to deal with. Is a kind equal to 1 or is it equal to 2? So that means this particular if structure is going to repeat itself for many, many places. Okay, can we agree on that? Let's see another example quickly. Let's see the second method we are trying to define over here. Okay, the second one is called, let's say, register. Okay, register. Let's say we want to register for this particular course. And then, let's say we simply say, for example, over here, let me just highlight in the same color so you can really see we say if this .kind is equal to 1, then we're going to set some maximum allowance for the resident student. Let's say each resident student can register for up to 6 courses, let's say, every resident students. On the other hand, let's say we say if this .kind is equal to 2, and then we're going to say maximum allowance should be, let's say, fewer. If you happen to be non-resident students, you can register for strictly fewer courses. And then the rest of the code will be you can imagine that, right? You can say if I already reached the maximum, I'm still trying to register more, I should somehow throw some exception, just some error. Otherwise, if I'm okay, I'm just going to do the standard updates as I see here, right? So now, I want you to look at the pink and the green. The pink and the green, they repeat themselves for twice already, simply because for every method that we are worried about right now, they have to distinguish between the students, right? Imagine that. Let's say we are dealing with realistically the student class for York University student class, right? It's not so surprising if you have to deal with 20 different or 30 different methods for the students. Then how many times do you have to repeat this structure? Maybe 20 times. Because every time you want to implement this method here, you have to somehow go over exhaustively what the kind of student I'm talking about right now, okay? Any question about this code over here? So why would this design be bad? Why is it bad? It might work, it compiles, it might pass all the test cases, but why would it be bad? Okay, I'm going a little bit forward here. This may not be so relevant to exactly this course, the context, because this course you're supposed to learn programming. I want to show you a little bit about software design, right? Every time you're trying to design your Java classes, you want to have certain criteria to make sure your design is reasonably good, okay? So now, very simple criteria we are having over here. Basically, what we have over here is, you can see this particular if statement structure over here is repeated for multiple times, okay? So the problem we have is repetition. Why is repetition a problem? So let's illustrate that quickly. Repetition would be a problem if you're trying to make some extension to your software. So what can be the possible extension? Let me show you, okay? Let's go to the next one. Oh, let me just talk about, have you heard about the word called cohesion? Maybe back in 1022. Anybody? Okay, let me explain that to you. Cohesion simply means all methods or attributes in a single class must be related to a single purpose. To make it a little bit more in layman's term, whenever you want to do a single class, do one thing and do it well. Don't try to do multiple things in a single class, okay? My first criticism to this design is, if you look at these two attributes, are they really serving the same purpose over here? Not quite. You can think about premium rates only belongs to resident students, whereas discount rate only belongs to non-resident students. But somehow we're mixing these two in a single class. So that's a poor design, okay? Again, it might work as far as this course is concerned, but I'm trying to show you what's really the good design, okay? That's criticism number one, okay? So later on, when you design your own Java classes, always think about whether all the attributes and methods I put together, do they relate to the same purpose? If they don't, you should really split them into different classes, okay? So they are somehow related to different purposes. Okay, one is for resident students, the other one is for non-resident students. Okay, that's criticism number one. Okay, number one. Let's see number two, which is easy, maybe a little bit more straightforward to see. Okay, number two. For number two, there is a design principle. Well, later on, when you take 3311, maybe later, there's a design principle called single choice principle. But don't worry about the term. I'll explain that to you. Intuitively, single choice principle tells you every time you want to make a change to your software, like a Java classes, there should be a minimum number of places you should make a change. Ideally, just one place, ideally. Okay? Let me say that again. Single choice principle tells you that every time, if you want to make a change it only one single place. Change should be done in a single place. Okay? Single here is really important, just a single place, typically. So now, it's a very simple principle to grasp. Let me ask you the following question, okay? Hypothetically, let's say we want to extend our student class, okay, using the current implementation pattern. And then I'm gonna highlight the question to you. We agreed before, we got repeated if statement, if conditions, right? We got always kind is equal to 1, we go to 2, okay? The first question for you. Let's say we are introducing a new kind of students, let's say. For example, remember we used to say 1 here means resident students. 2 here means non-resident students, right? Let's say, for example, we want to introduce a new kind of student. Let's say 3, okay? It's integer, so it should be big enough to hold it. 3 will be, let's say, international students. Let's say international students, a third kind. Can you tell me, in the student class on the left-hand side, we don't have to change anything. We just give the implicit assumption that when you pass the kind over here, it could be 1, or it could be 2, it could be 3. Okay? Question for you. On these two places, how many places do we have to modify the code in order to reflect this introduction of the new kind of students? Is it just a single place or multiple places? Okay, if you say multiple, that's a good sign. Can you tell me, first place, where should I put it? Stephen?
First method, iteration, and else if.
This dot kind equals 3, exactly. Let me write it down. That's the first place. So over here, the first place, I'm going to say else if, and then I would say if this dot kind equals 3. And then I will do something according to the international student I just introduced. Okay? Would there be another place I need to introduce this? Another one, yes, where? Yeah, exactly right. Okay? Let's say maybe for international student, we even restrict the number of courses they can register. So what I will do is I'll put it exactly where you should put it. Okay? Basically, we're going to introduce another else if over here, and then we're going to say this dot kind equals 3. In that case, we do something over here. So now notice that we have to repeat similar kind of changes for the if statement over here. One place is here, the other place is over here. Multiple places. Wouldn't that be nice if we can modify just a single place? Let's imagine even in the extreme case. Let's say realistically, the university have 20 kinds of students, right? In that case, wow, we have to actually repeat this many for the if statement so many times. And every time we want to introduce a new kind, we have to modify every one of them, the else if. Okay? That's the second criticism. So this is my response to you guys who actually gave me the response about this is how you will implement the student management system, okay? By using an integer value kind over there. So my response would be, it might work programmatically, but it will violate 2 important design principles. Number 1, cohesion. Number 2, single choice principle. Okay? Don't worry too much about the terms, right? As long as you grasp the idea, I'll be happy. Okay? Guys, any question about the first design? Before we move to the second one, we don't use inheritance just yet. I want to show you different varieties before we get to inheritance. You will see that whatever criticism we add to the first 2 versions, they will be eliminated in the inheritance. That's why inheritance is so handy, design-wise. Okay? Is it okay if I move on to the second one? Okay? The second one there is going to be a little bit different in the following sense. Rather than having, you can think about as follows. Version number 1 that we just talked about, we simply got a student class where we got integer kind, right? That's what we just talked about. Version number 2, we're going to say, well, since you talk about cohesion, cohesion simply means do one thing and do it well. Somehow you got premium rates, you got discount rate in the first design, the single class. Why don't we try to fix this cohesion issue here? So what I would do is I would create 2 classes instead. I would say resident students is going to be 1 class. I got a code, don't worry, I just sketched the idea for you. I got resident students, and also I got non-resident students. And now I know pretty well, in the context of resident students, I should put premium rate here only, right? In the case of non-resident students, I should put discount rate over here. So now I can resolve the cohesion issue, okay? So this is the issue of cohesion. Okay, so here, cohesion resolved. Okay, that's a big picture. However, the second design, as we'll see, cannot really help you resolve the single choice principle, which means we still got code duplicates. That's a problem. Okay? Let's see how the second version should look like. Let's go over a little bit of code quickly. Okay? And then I'll ask you some questions to help you think. Okay, so that's a problem we are solving. Okay, we already got this first version done. Okay, this is the second version. Let's say we define a class called resident students, separate class. And then for the resident students, we got name, we got registered courses array, and also we got number of courses. That should be very familiar to you. And then we also got, for cohesion purpose, only for resident students do we have premium rates, right? No discount rate in this class. And then we got resident student constructor, which will simply just initialize the array to be size 10, let's say, for example. And then for register, we simply try to add the course into the array, okay? And then let's get tuition. How do we calculate the tuition? Somehow we have to calculate the base amount, which means simply go through every course the current student is registered, add up their fee, okay? That's what the loop is doing, okay? That one, I don't need to bother you too much. And notice that in the case of resident students, I need to say whatever tuition I calculated, don't forget, we're going to charge them higher. So we're going to multiply by premium rates. Any question about the code shown so far? Any question? Okay. If no question, I have a question for you. Okay. Let's say in the next slide, I'm going to show you the class for non-resident students. Would you imagine that it's going to look very similar or very different from resident students? Similar? Can you tell me, if you say they are very similar, let me just highlight the differences. Can you tell me exactly how they will be different from each other? A rate? The rate, for example, discount rate as opposed to premium rates. And what about get tuition? What will be the difference? You got to apply discount rate as opposed to premium rate, right? I'm not sure if you saw my visual hints. I highlighted for you. Okay, good. Just in case you didn't see it. Basically, whatever I highlight in yellow over here is going to be the difference when I go to the non-resident students class. Let's see quickly. And notice that they're separate classes, separate. So we got lots of duplicates. That's the point. I'll show you a little bit on Eclipse just in a moment. Let's say for the second class, right? Remember we got 2 classes. We just have seen resident students. Let's see non-resident students. Name is different for sure. And then you see that we have to redeclare name, register courses, and number of courses in a different class. Repetition already. Would it be nice if we can define all these attributes in a single place and let them share? That would be very nice. And then here we got discount rate. This itself is fine because this is going to be coherent. And then we simply got constructor here. You can see just the name of the constructor is different. The way you initialize the name and also initialize the array is just identical. Again, lots of repetition. What about register? It's completely repetitive. And if you look at the get tuition, it's partially repetitive. The way I calculate the base amount for the courses will just be the same. The only difference is Once I have done the loop, I have to say now apply the discount rate as opposed to premium rates, right? The only agreement I want you to have with me is the two classes have lots in common, lots of repetitions, okay? Good. So why would this be bad, right? That's a question. Anybody want to speak up for any thoughts?
It's bad because it's redundant and you want to avoid redundancy in order to like save time and make sure your program utilize those resources for most of the.
So when you actually say to utilize resources, are you talking about the efficiency of the program? Okay, I would say in this course, we only talk about program efficiency at the end. I would say this one here, don't worry about efficiency, okay? It's mainly about the design. When you got lots of repetition, remember the principle I talked about? Single choice principle. Anyway, the name is not important. I just want to grasp the essence of the principle. Now, what I'm going to show you is some very simple test cases just to see everything works, and then we criticize on that. That's the plan. Okay, so now let's have a look at some test cases. Let's assume we got a course class. Okay, that was simple. Just you got a title, you got a fee for the course, and then we got some tester over here. Okay, I'll go over the tester line by line quickly with you, and also visualize that quickly. So these are the two classes we just talked about. We talk about resident students. Also, we talk about non-resident students, right? The part that's highlighted in yellow are the only parts without the repetition. All the rest, we got lots of repetition, but it might still work, okay? Let's have a quick look, okay? I'll trace the code together with you with a little bit diagram, okay? I already drew most of the diagram here just to save time, okay? Let's go over it quickly, okay? Let's now see line by line quickly. Line number 1 and 2, we simply try to create two course objects. We got C1 and we got C2. Okay, basically 2030 and 3311. So 2030 and 3311. Okay, and $500 each, let's say, for example. 500. Okay, that's what these lines will do. And then we got C1 and C2, right? C1 and C2. And then let's see the line over here. The first one, let me highlight it in blue. This one here. Okay, we're going to create a resident students object called a gym. And then we'll have some name. Just in the visualization for saving space, I don't have the name, but just remember we have a name for the students. So we simply say gym is now going to point to this particular resident students object. Initially, we got an array, let's say of size 10. And then every slot is pointing to null. And then the next point, the next line is important. We say gym dot set premium rate, right? To be 1.25. Set premium rate is just some mutator for the premium rates. So what I will do is I'm going to say over here, so 1.25. So premium rate for gym would just be 1.25, right? That's the premium rate. Very good. And then we say gym dot register C1, gym dot register C2. Okay? Just add a course. That's very easy to do. When you say register C1, so C1 is referring to this object, so now register for that. And C2 is just second course, just register for that, right? We have done this for many times. I assume you have no trouble with that, okay? Let's do the second student very quickly, and then we'll see the difference. The second student is going to be, let me use green, okay? Non-resident students, Jeremy, is going to be non-resident students. And then we're going to set its discount rate, assuming that we got discount rate mutator method. Okay? What I will do is I'll write it down over here. So we got Jeremy, let's say the Jeremy over here, and then 0.75. So 0.75. And then we're going to register Jeremy to the same set of courses. Let's say Jim and Jeremy, they are classmates, let's say. Okay? C1 and C2. C1 first, followed by C2. So that means the first course is also going to be C1. The second course is going to be C2. Guys, are we okay so far? Okay, so now let's see how things work. Let's have a look at two lines of execution over here. Let's say pink. Number 1, Jim.get tuition. Number 2, Jeremy.get tuition. One thing to note. The context objects are different. The first one is Jim. The second one is Jeremy. Agree? Okay? The get tuition, it seems like you're calling the same method, but are you? You're not, because remember, we got get tuition in the resident students class. We also got get tuition in the non-resident students class, right? They're different methods, but they just happen to have the same name. Just remember. Okay, let me just mention that to you. So now, if you look at that, the first one, let me use blue. When you say gym.get tuition over here, the get tuition actually comes from the resident students class. That's get tuition. Okay, because we know that gym was declared to be of type resident student. That's why it's come from that class. Okay. Similarly, if you try the second one, let's put it in green. When I say Jeremy.get tuition over here, the context object is Jeremy, and Jeremy was declared to be of type non-resident students over here, right? That's Jeremy. So that means when we call get tuition here, it's going to be the get tuition from here. Just different methods. They just have the same name. This is the runtime behavior when you don't have any inheritance. Okay, what will be the answer quickly? What you will see in the slides is basically if you try to execute these two methods, what they will do is for each one of them, they will simply add up the courses they have in common, right? In that case, the base amount will just be 1,000 for each case. But now remember, for Jim, it has the premium rates. For Jeremy, it has the discount rate. You got to apply them respectively, right? So in the case of Jim, it's going to be 1,000 multiplied by 1.25. In the case of Jeremy, it's going to be 1,000 multiplied by 0.75. So just different fee they got to pay, even though they are classmates. Okay, guys, hopefully you're not lost yet. We haven't even talked about inheritance, not yet. Okay, any questions? Later on, once we got our inheritance version, we're going to see a similar test. In that case, I can assume you're okay with this. So that's just the first time we're going to do it in more detail. Okay, it seems to be working. This version here, even though we don't have inheritance. So now again, we are trying to really be as ideal as possible. So let's criticize on this particular design, okay? So now if you see the slides, it will pose the same question I asked to you in the first version. Okay, let's have a look. Okay, they have lots in commons, okay? So whenever you have lots of repetition between the two classes, you can see lots of repetition, right? As we talk about lots of repetition between these two classes, lots of repetition. So now duplicates will just make it harder for you to maintain your software, meaning that if you want to introduce some changes, it's just harder to do so. Okay, let's see a different kind of changes. Okay, that's the single choice principle if you want to look for definition. I didn't say it's called single choice principle here, but it meant the same thing. Every time, if you want to change something, let's say we want to change a registration policy for the student, let's say, you have to modify more than one places rather than a single place. So that means we are violating single choice principle. Let's see, I'll just go over the first change with you, okay? And then we'll go a little bit Eclipse, okay? Guys, I have a question for you over here. Okay, again, so these are the two classes that we just looked at, right? Lots of repetition. And now let's say this. Previously, when we want to register for students, we simply add the course to the array. Similarly, for non-resident students, when we want to register, we also add the courses unconditionally. Let's say we want to introduce some kind of a constraint for the registration, let's say. Something like, if the number of courses is already reaching some maximum allowance, let's say there's a constant, can be 5, can be 10, can be some number. It's reaching that, we're going to throw some new illegal argument exception. Too many courses for the students. Okay? Let's say that's a new policy we would like to introduce. Now, for this particular change, can we possibly just modify one single place to fix the code? Okay? How many places do we need to modify? 2 places? Would you agree that we have to modify basically both this course over here and this course over here? You have to. Okay? Basically, you can think about what you have to do is this particular if statement here is going to be introduced to the register method here, and also it's going to be introduced to this particular register method here. That's what you got to do. Okay? So multiple places, that's not good. Imagine that if you have 20 kinds of students for this particular design. So that means you got 20 different classes for the students. In that case, how many places do you need to modify? 20 different places. That's not very pleasant, is it? Okay? That means it's not a good design. A good design not only works, but also make it very easy for you to maintain. And there's a maintenance problem here. I want to show you something very quickly, okay, before I go to some conclusion. I make some source code available to you on the web, on the lectures page. I encourage you to play with it. When you open the source code, I'll read it to you, it's a bit small. It's called example inheritance projects, okay? You will see two packages over there. One is called without inheritance. The other one is called with inheritance. If you go to the without inheritance, I would like you to try the following, okay? There's an exercise for you. If you open the class for resident students and also non-resident students. So these are the two classes, okay? Okay, sorry about that. Let me open again. Okay, we got these two classes, resident versus non-resident. So now, if I want to introduce my changes over there, I want you to just try by doing that yourself. Okay, I'll just do one for you. I know that if I want to introduce that new policy, you got to say if number of courses if that's larger than or equal to, for example, 5, just say for example. In that case, I'm going to say some error. Okay, let me just make sure. Okay, I call it NOC in the code, sorry. I'll just say NOC. Okay, I'll say NOC here. In that case, I'm going to give you some error. Otherwise, I'm going to do the registration as normal because this has not exceeded the maximum capacity just yet. You can see what I have done was a change to a single place. Do I need to do another place? I have to. I got to go to the non-resident students and do exactly the same thing, possibly by some copy and paste. If you have to do so many copy and paste for your classes, it's not a good sign. Okay? Anyway, I just want to show it to you quickly. Okay, so now that's the first change. There's another change you can try to do. I'll leave the exercise for you. Okay, sorry, let me go back to iPad. Another change you can try is, let's say we want to change the way we get tuition. Okay? Currently, we simply calculate base amount multiplied by either premiums or discount rate. Let's say we want to introduce another one called inflation rates. Again, how many places do we need to modify? 2 places, right? For each class. Okay, that's an exercise for you. But the conclusion is going to be the same. You're going to modify multiple places. That's not a good design. Okay? Guys, any question up to now? Okay, a final exercise we have to realize together. And this will really eventually convince you why inheritance is good. I will revisit this again later. Okay, but let's talk about it now. Before I show you the code, sorry. What I meant to say is this. Remember the original problem description. What we want to have is a student management system. A student management system, obviously, is going to store the collection of students. Either they are residents or non-residents. Now, without the inheritance as is, how many arrays, or how many linked lists, or how many array lists do you need to create for this student management system? That's the question. Well, the way we created the two classes, resident students and non-resident students, they have nothing to do with each other. They're simply unrelated. So you have no choice but you have to create one array of resident students, another separate independent array for non-resident students. You cannot get away from that. Okay? Let's see. So what you have to see is you will say student management system, that's the final class we're going to define. Let's say 2 arrays, resident students, non-resident students. And then let's see a little bit code. I'll go over that with you quickly. Okay? Let's go over diagram just in a moment. Okay? I already drew them, so to save time. Let's say this. So we have number 1 array. We got another array, number 2. Okay? We got 2 arrays. And then we got 2 separate counters. So you can imagine that. How do we extend the system? Let's say there are 20 kinds of students. How many arrays do we need? 20 arrays. How many counters? 20 counters. They work independently somehow. It might work programmatically, but it's poor design because you got lots of repetitions. How? Let's say, for example, you have some mutator here at single resident students into the system, you will simply say resident students here, and then you simply add it to the array. Okay, that's number one. Number two, you can define another method over here, and then you just gotta add it to, just different type. Wouldn't it be nice if we have a single add mutator method just for all kinds of students? But currently, it's simply not possible because all the student classes are unrelated. Okay, one more thing. Let's say we want to define this particular method called register all. Let's say all the students will take some common course, so that's why we want to register them all for this course. So now you can see that unavoidably, I have to write two separate loops. One for adding the course into RSS of type resident students. The other one, I need to add into NRSS of type non-resident students, right? Because I got so many kinds of array, I got to do so many loops accordingly. Okay? Again, you can see the student management system here. You might be wondering, why is this wrong? You might be wondering because you haven't seen how elegant the solution is for the inheritance, but we'll see that, okay, in a few lectures time. Okay? Keep this example in mind. You will see that in the final solution using inheritance, only a single array, only a single counter, only a single loop. Okay? And it doesn't matter how many kinds of students you have, doesn't matter. Okay, at the runtime, okay, you don't have to worry, we don't have to draw anything. Just remember that we got one array just for resident students, right? You can see each object of resident students. Another array over here for non-resident students. You can see each object of different types. Okay? That's how the student management system is going to work for version 2. Okay? And we know that it's not so good. So many repetitions. And you can see you got to declare so many arrays. That's not good. That's not acceptable. Okay, that's something we just talked about. And then for those of you who are interested, click on this link when you see the slide. It shows you, if you use inheritance, how the student management system will look like. Okay, you can do that later. Okay. So what we will do now, what we have done, we have seen two versions without inheritance. Each one of them suffer from some design issue. First version suffer from cohesion, suffer from single choice principle. The second one satisfy cohesion, but it does not satisfy single choice principle because of repetition. So now we want to see how we can satisfy both using inheritance. So now we'll officially enter inheritance. And today, hopefully I'll get there. What I want to do is I'll show you a little bit code, and I want to talk about two concepts right away to give you some intuition, but we'll get there. Okay. So what we will see conceptually is we're going to have some resident students class and also non-resident student class. It seems to be so far similar to what we have done in version 2. Okay, seems to be. However, here's a critical thing. We're going to introduce a concept called parent class. So these two classes are so-called child classes, which means somehow they are children of some parents. And just if you think about realistically, right, usually children inherit something from their parents, right? Either their appearance or maybe their wealth or whatever, right? They will inherit something. The student class will be considered as the parents of both the resident students and non-resident students. Or think about these are siblings. Okay? Extends is a key word you have to know for inheritance. Okay? Now, what you will see in the code is as follows. You will see that we're going to define the student class first, where we're going to factor out all the common stuff among the two kinds of students in a single place, student class. And then we're going to declare in the code to say resident students extends from students, and also non-resident student extends from students, so that all the stuff that's defined in student class will be inherited into these two classes. So that effectively eliminates the repetition problem we have. I'm going to show that to you. Okay? So you can see it's really a long story to tell. Okay, just make sure you follow every step, right? But interrupt me if you got trouble. Okay, that's kind of the conceptual model we're going to have. Let's see how exactly we can do it. Okay, I'm going to show you the code a little bit later, but let's just go for a slide or trace the code a little bit later. We have a student class, and unlike the first design, remember the first version, we got an integer kind. We don't have that. Okay, what we get is we got name, registered courses, and number of courses. So these are the common attributes for all kinds of students. We put it here. Okay. And also, we got a constructor here called students. And we simply initialize the name, initialize the array. And somehow, somehow this block of code will be shared by the two kinds of students. And then we have register, which is completely shared between the two kinds of students. And so now, pay attention to this. You can see the get tuition method here. Did you notice that we didn't mention any premium rates? We didn't mention discount rate. Simply because as far as a general student is concerned, we don't worry about the discount rate or premium rate just yet. We will see that a little bit later. Okay? Any question about this? You can see the amount of code we have to write is somehow similar, but it's more about how your application can scale later when you got more kinds of students. That's the main issue. Okay, so now we're going to see exactly how we can define the children classes. We got two children for now. Let's see. Number one, we have resident students. You have to declare to say resident student extends students. So this is a very, very powerful notation over here. Not just to say that every attributes or every line of code, let's put it that way, every line of code including attributes, accessor method, mutator method, and constructor, everything you declare in the student class will be available for use in the resident student class. You can use it if you wish, or even better, sometimes you can redefine them if you wish. But we'll talk about what I mean by redefine. Okay, extends is the word you should know. And then for coherence, for resident student, the applicable rate will be premium rates. So that's why we put it there. And then we got the constructor over here. And now we do not want to repeat the constructor to initialize the array and the counter. How can we do that? There's another keyword for you. Oh, over here, sorry, I already showed it. Can you see super here? Okay, I'll show you what that means. Okay. So now that's basically the code we have gone through. Okay, we have already seen the student class. Okay, that one has been seen already. So now I want you to focus on this class over here. Resident students. So let's look at this line here. If you look at the constructor for your resident student class, you can see super. Okay? When you have inheritance, when you use the word super, you're basically saying, I want to go to the same method that's in the parent class, and then use that verbatim. That's what I'm saying. In the case of constructor, you simply say super here, and then effectively, you are calling this particular constructor over here. That's basically what you're doing. Okay? Effectively, what you're doing is, you can think about conceptually like this. So this is basically saying students, let me make it a bit thinner. Okay. And then I simply pass the name over there. So I don't have to say anything else, okay? I'm just effectively reusing the whole block of code. That's how you use super for constructor. You will see a similar usage in just a moment, okay? Guys, any question here? You're fine? Question?
Super is basically what extends, like the part after extends.
Yeah, if you think about super, well, you can only use super when you have a parent class, right? So that means you got extends. So when you say super here, especially, let's say for the constructor, you're calling the parent version of the constructor. That's what you're doing, okay? Good. And now let's see some a little bit more code. Let's go on. Okay, so now what about, notice that we did not declare register here. Did you notice that? That's the whole code. That's it. That's get tuition. So that means we can completely forget about declaring register again, so that we avoid duplication. The register will just be inherited verbatim in this class. Okay? And now let's look at one more line, one more method, get tuition. Now you can see what we're doing here. Basically, we're saying, let's see, we're using super here, right? Let me show you the code on the iPad. Okay? Now let's look at that. I want you to pay attention to this line here. Okay? We are basically calling super. You can think about super is referring to the parents. So this line is saying, first of all, before I can define the get tuition for the resident students, first of all, go to my parents. Ask them about the definition for calculating the get tuition. Okay? What it is saying is, I'll show you here. You can see super over here is referring to the parents. And then you're talking about go to the get tuition method. So this one here is basically talking about go to this particular method over here and calculate the tuition. Whatever that's returned, you're going to save that into the base. Once I get the base, I'm going to apply the premium rates. So I don't have to repeat the base amount calculation. Just use super. Guys, make sense so far? Okay? It makes even more sense when we talk about how the other child classes can also use similar mechanism. You can see there's no duplication of the code. That's really important. Okay? Okay, let's go a little bit further here. Okay, so now let's go to the other class. Okay, but this is more basically what I just said. Okay, you can refer to them when you study the slides. The other class we're going to talk about will be non-resident students. Okay, very similar. I'll just go to iPad directly. So now let's have a look quickly. We got this class called non-resident students. Of course, it extends student. Extends is really important. Okay, and then you can see we for coherence we say double discount rate as opposed to premium rates, right? They're different. And then notice that for the constructor of this particular class, we simply say super. What's super here? Which class are we talking about? Students, exactly. So what I would do is, I'm basically talking about, so this one here is referring to the same block of code over here. We are just reusing it. No repetition, right? And similarly, if you think about how the get tuition method will be defined over here, what we will do is, first of all, we try to calculate the base, in which case we simply say super.getTuition. And the super over here, quite obviously, is referring to the class over here. And super.getTuition is now referring to this block of code. So we are using that for the second time. Okay? And then after we have calculated the base, we simply say discount rate. Right? That's a difference, right? You can see the difference between the two versions over here is like this. They both of them use base. On the other hand, one version uses premium rates, the other version uses discount rate. And we minimize, or we eliminated duplicates completely. You can see there's no duplicates here. That's a much better design, especially when you got many kinds of students. You don't have to duplicate any code. Okay? I'll pause a little bit for you to ask questions. Yes?
So the resident student and non-resident students, their parent class is student.
Yes.
What if we made another class that's parent class is like resident student?
You want to make another parent class for resident students?
Let's say resident student was a parent class of a new class that we made.
Okay. Okay, good question. I always got this question. That's absolutely makes sense. Okay, basically, to what extent can you use super? Okay, let me make it a little bit more general. Your question. Okay, guys. Fortunately, for super, it's not that complicated. You can only refer to your immediately above parents. Okay, but let me illustrate to you. Okay, let's say this. I got a class called A here. Okay, I got a class called B here, and I got a class called C here. Okay, three classes. C extends B, B extends A. Okay, you can think about B is C's parents, A is B's parents. Implicitly, A is more like C's ancestor. Right? Make sense? Let's say, for illustration, we have a method called M1 over here. Okay, and then somehow we have another method called M1 in B as well. And we got another method called M1. We try to redefine the definition for M1. So now, question for you. Over here, if I say super.M1 versus over here, if I say super.M1, okay? Am I referring to the same M1 in both cases using super? No. Not really, right? Okay, you only refer to the immediately above parents. Okay, that's the fortunate part, so you don't have to worry too much. Okay, let me make it straightforward. So when you say super.m1 over here, you're basically talking about this m1 because A is the parents, right? And over here, When you say super.m1 over here, you're referring to the m1 over here, immediately above. Okay? You cannot say, for example, super.super. No, you cannot do that. Okay? You can only say super just once. Yes?
Is there a way at all for C to refer to A's M1?
No. Your question was, is it possible? Okay, the question was, let's say we got M1 here, we got M1 here, and also we got M1 here. Is it possible for the M1 here to refer to the M1 here in A? You jump the level. The answer is no. Okay, I would say I will save this part a little bit. Maybe once we talk about overriding a little bit more, we can get back there. Okay, good. Okay, so now let's go back to the code here. Okay, guys, any question about this code here? So the two keywords you have to know for inheritance. Number one is extends, the other one is super. Okay, these two keywords. Question.
Can class have two parents?
Oh, good question. Can a class have two parents? The answer is no. For Java, for C#, they do not support the so-called multiple inheritance. They do not. So you can only have only one parent. You can only say extends A. You cannot say extends A and B. No, you cannot do that. Okay.
So for parent, when each child calls the parent, does it store its attributes? Does it have the parent store multiple attributes for each child?
Good question. You're basically asking about how do we visualize the object at the runtime. It's exactly the next topic. Okay, let me just answer very quickly. Basically, you can think about the way we share the code is basically just statically when you develop the code, right? Conceptually, there's only a single place where we put these common parts. At the runtime, somehow you will see individual copies of the attributes. But let's see exactly what I mean. Okay, we'll definitely get there for sure. Okay, that's exactly the next one. That's good. Okay. Let's see how we can visualize each object over here. So now we have basically, let's say this. When we declare S, when we declare RS, when we declare NRS, S is of type students. RS is of type resident students. NRS is of type non-resident student, different types. Guys, remember back when I talk about equals method, I promise I'll give you the complete story. Now is the time to start talking about it. Okay? So number one thing you want to remember is this. Every time when you're trying to declare the variables, okay? You can see I try to declare S to be of this type, RS to be of this type, and NRS to be of this type, okay? So these are called static type. And the word static here has nothing to do with static variable, nothing to do with it, okay? They're completely different. When I say static type, I simply mean the type I declare the variable to be. Once it's declared, it never changes. Okay, we'll revisit this concept over and over. Okay, for now. Okay, so now how do we visualize that? You can see in the case of student, let's just look at that definition. What do we have for students? Each student has name, registered courses, and also number of courses. So these are the only three attributes you have. So that's why at the runtime, what you will see is you got name, number of courses, and registered courses. Any question about this part? Okay, now, the tricky thing is about how do we visualize a child objects. You have to do a little bit of accumulation. Not only that, the attributes you declare in the child class, but also those that's inherited from their parents should be included. So what do I mean by that? How do I figure out the attributes for resident students? The way I do it, number one, I look at what's being declared in this particular class. The only attribute is premium rates. So that is why I would say I will put premium rates for the resident students class. Similarly, I will put discount rate for the non-resident students class. And what else? I have to somehow look at every parents, grandparents, great-grandparents, all the ancestors for this particular class to accumulate all the attributes. Those will be the attributes that should be visualized. But in this case, it's simple. The only class that's parents of resident student is students. And what do we have? These three, right? So that is why you will see that when we visualize, you will see for resident students, this part is new. The remaining part here is simply a mirror of what's in their parents, but they're independent copies. And similarly, you see for non-resident student class, you got discount rate, which is new. At the same time, you also got exactly the mirror of their parents. Any question about visualizing objects here? Please, any question, it's time to ask. I'll take your question first, and yeah, go ahead.
So for the student, the first one, we declare the student Stella, and she has to be a resident or non-resident anyway. So how would we?
Okay, so you're basically asking about if we simply do the parent class, let's say students, that one doesn't really have the premium rate or discount rate. How do we deal with that? We'll get there a little later. Okay, question? Yes.
So like what you showed in the previous slide, if you are using the extends and the super, you're going to get all the attributes of
Exactly.
the main class.
Yes.
You get all the methods as well.
Yes, you can think about when you use the super and also when you use the extend, it's only when you develop the code. It's for the compiler to know how to visualize your object and store things. Those are the details you don't have to know as a developer. At the runtime, you can think about it works just like version 2 at the runtime. Works just like that. However, at the compile time, it saves you so much work about maintenance. That's how you can think of it. Yes, yes, one moment.
So like if I have a method called show student information in the main student class, and then if I want to access information for resident student, I would just do something like resident student dot.
Yep. Yeah, it's good. You're basically talking about how can we manipulate the object. We'll get there. Don't worry. Yeah, we'll definitely get there. I'll take a question. Just one moment. So if I simply say S, I can definitely get access to name, number of courses, and register courses. That's it. If I say RS, in that case, I can get not only these, but also premium rates, right? Let me say that up to now. Okay. Question?
If the student object had like two of the same attributes, for instance, like double weight, double height, for example.
Sorry, can you say that again? I don't quite get your question. Sorry.
It's the student object,
Mm-hmm.
two attributes of the same type, like double weight, double height.
Uh-huh.
When you said super, has to double, which of the constructors work?
You talk about multiple versions of the constructor, right? If that's what you're talking about, okay. Maybe not
Same parameter.
the same parameter, okay.
Never happened?
No, actually, basically the way you call the, you know what? Speak to me after class about your question so I can answer that a little bit more appropriately in the class to share. Okay? Otherwise, if you do it on the fly, it can be messy. Okay, just approach me. Okay, guys, any question about this? Okay, now, let's do a very important exercise together. Remember the handout I gave to you? Now is the time to get it. Turn to the back page. You will see that over here. I'll tell you what this exercise is about. I'll explain to you and also the table. The table is completely empty for now. Okay, we're going to fill it in together. Don't worry. Let me explain to you what's my concern right now. Okay, let me review very quickly with you. So this is basically like a summary of all the classes we talk about. Let me talk about very quickly. We got a student class where we got name, registered courses, and also number of courses, right? Also, we got a constructor here. We got a register method. We also got get tuition. Okay, that's a parent class. For the resident students class, one of the child classes, we simply got the constructor, and also we got some new attributes called premium rates. Also, we got another method called set premium rates, right? These are new. And then on the other hand, for get tuition over here, we are trying to use super, right? There's a special term for this. Every time you inherit something from your parents, but you want to redefine it, you want to give a little bit more new definition to it. It's called overriding. Overriding. Overriding, or you can simply say redefinition. It's on your slides, don't worry. Okay, apparently we're saying that get tuition is somehow overridden or is redefined in the resident student class by applying the premium rates. Similarly, we also got non-resident students, and then we simply say get tuition, right? Also, we try to redefine that. And also, we got the constructor, we got discount rate, which is new. We also got set discount rate, which is also new. Okay, that's the structure. Okay, so now let's see what the exercise is about. Straight to the points. Let's say I declare 3 variables over here. I got S, I got RS, I got NRS. I want to know, when I, let's say on the Eclipse, or even just on the paper, if I say S dot, what can I put on the right-hand side of the dot? Can I put name? Can I put registered courses? Can I put number of courses and etc.? Basically, I select all the attributes and all the methods and put it on the table in this row over here. I want to know if I say S dot versus RS dot versus NRS dot, what am I allowed to write to make it compile? That's the question. Okay. Let me just repeat in a slightly different way. The goal is to say, given that these 3 variables are declared to be students, resident student, and non-resident students. Okay, I'll put it here. So these are called static type. Again, static type. Given their static types, we can decide, or the compiler can decide. When we say S dot, what should be there? What can be put? When we say RS dot, what can be put on the right-hand side? And when we say also NRS dot, what can be put? Okay? Let's do the first row, 1 column by 1 column together. Okay? Question? Yeah, just check mark, basically. Yeah, exactly right. Yeah. All I want is either check or cross. Okay, let's do the first one together here. Okay, I'm going to use color green for check, red for cross. Okay. Let's see this. The first one. Do you think I should be able to say S dot name? Okay, I tell you what, this is how you judge. You want to pretend yourself being the compiler, even though you are not. You want to pretend yourself is. Okay? The exact way to judge is by saying, if I try to make a call here, S dot, look at the static type for that particular variable, students, and see what is available in that particular class for the static type. In that case, can I say S dot name? Can I? Yeah, because name is defined exactly over there, right? For S, the static type is simply just students. And for students, we have name, registered courses, and number of courses defined. Right? Agree? So now that means we should put check for name. We should put a check for, let me just say this, name, registered courses, the registered courses, the array, and also number of courses, right? So these are the 3, basically. And I should also be able to say register, because register is here, right, in the same class. And also get tuition, which is also here, right? Any question about these green ones I just put, the green checks? So now, here's a question. Very important. Can I say S dot premium rates? Can I or can I not? No. The principle is very easy. Look at the static type for S, which is students. Does the student class define premium rates? No, it's only in the later class in the child. Okay, so no. As easy as that. For this one, I'm going to write down the reason for you. Okay, it will simply say no, because PR is only in resident students. Okay, so this one is no. What about set premium rates? Can I say S dot set premium rates? Also no, right? Because set premium rate is only in over here, in the child class, which is not in students, right? Okay, also no, and similarly for discount rate and also set discount rate, right? They're simply not defined. Given that we have got this first row, I hope you got a little bit of intuition. I'm pretty sure you'll get confused later. It's guaranteed, but it's fine. You want to struggle a little bit, okay? Given the first row, can we do the second row, please? Now, can I say RS dot name? Well, why? Residence, first of all, RS is of type resident students. But resident students does not define any attribute called name. It's inherited, exactly. Okay, well, I'm just trying to confirm with you, right? So the name over here is directly inherited to resident students. So even though it's not there explicitly, it is there. Okay, so now, similarly, could you agree? RS should be able to say rs.name. And RS is basically resident students. And resident student here inherits everything from the student class. So we should be able to say everything here. Okay? So now, can I say RS dot premium rates? Yes, it's defined exactly over here, right? So now it's not a problem to say set premium rates. Yes. What about discount rate? Because discount rate is only here, the other side of sibling. You don't inherit anything from your sibling. All right, so now it's interesting, huh? What about the next one? Last row. So it would be somehow similar, right? Okay. Similar principle. First of all, we know that NRS statically was declared to be non-resident students. Non-resident students over here, which inherits everything from the parents, and including everything that's declared over here. So that's why you will simply see the following. Can we say NRS.name? Yes. Register courses? Yes. So far, these are the attributes or methods inherited from the parents, so that's fine. Can I say NRS.premium rates? No, right? Because NRS, being non-resident students, does not define things that are in its sibling. Okay, so it's not. Okay. Okay, let's now this guy here. And should I be able to say, let's say this, NRS.discount rate? Yes, because discount rate is exactly over here. Okay, so now you'll be fine. So now one thing to see, everything that was declared in the parents will be available to all three objects, right? So now let's see, let me say this. You can think about all these over here. So these are common attributes or methods inherited from parents, inherited. On the other hand, you can see the other side over here. Let me say, the other side you can see, so these you can see only something that's unavailable, only something that's available, something that's unavailable. Okay, you can think about this second set. So these are the subclass specific attributes. Okay. Okay, I'm doing well with the time. I still got 15 minutes, 10 minutes, about 10. Are we okay before I make a final conclusion, before I go to some very important exercise with you? Basically, what we have seen in this table here is a very important word, expectation. I'll write it down. Every time when you declare some type, okay, I'll say T, can be students, can be resident students, can be non-resident students, and some variable V, okay? And of course, you got something over here, okay? So now, when I say V dot, what can I put over here? The stuff you can put in order to make compiler happy is called expectation. And the table from the previous one tells you exactly the expectation is like for either S of type students versus RS of type resident students and NRS of type non-resident students, right? In general, does a child have more expectation than its parents or the other way around? The child has more expectation, right? Because when we do inheritance, you can definitely introduce as many new things as you like in the child classes. So in the child class, you may have more expectation, typically. Okay? Okay, let me see a little bit more. Okay, let me write it down. Child class has more expectation from the compiler's point of view. Then parents. Okay, that's really important. I'm trying to make things intuitive to you, right? Before we get to something that's complex. Now, I want you to really emphasize, really reinforce this expectation idea. Okay, let's now consider this exercise here. I think I can only do this for today, hopefully. One of the most important topic about inheritance is called polymorphism. You got questions? Yes. Expectation simply means, okay, let me just review that quickly. Expectation simply means, over here, when you declare your variable v of certain type, compiler will then decide, when you say v dot, what methods or attribute can you call in order to make a compile? Okay? Good. That's good. Expectation. Guys, let's consider this. Okay, this guy here is simply just a reminder. Okay? Let's consider the following set of code. I'll go over that with you. I have questions for every one of you. Give me your opinion. I'll get to this a little bit later, next week. Sorry, next time, not next week. Okay, so now that's a table we just talked about. And now let's say this. We create S of type students, static type students. That's a hint for you. And then we have RS of type resident students. We have, and also we set the premium rate to be 1.25, okay? And then we have the following two lines. Line number 4, I say S is assigned to RS. Line number 5, I say RS is assigned to S. Just tell me your intuition. Which line do you believe is valid? You can say both valid, you can say both invalid. We can say one of them is invalid. One moment. Usually, I would like to take a vote. Usually, please participate, right? Think about it. Question is, do you think line number 4 should be valid, or you think line number 5 should be valid? Either 4 or 5. Okay? Just according to your intuition, okay? Of course, whatever the voting result may not be the scientific truth, right? I just want to see your intuition. Okay, let's start a vote. If you believe line number 4 should be valid, raise your hand. Okay, some. What about 5? That's good. R is assigned to S. So it seems like more people believe line number 5 should be valid, positive, right? That's wrong. 4 should be valid, not 5. That's okay, you know, since I only asked for your intuition. When you answer a question in the lab test, you don't go with your intuition, right? You don't go with that. That's good, okay? Now, the way to reason about, I tell you what, the rule is easy to memorize only for this semester. You don't want to only memorize the rule. You want to remember how I reason about it. I'll do that before we end today, okay? Have you guys learned about proof by contradiction? Yes. Yeah. To prove that something is false, I'll assume that it is true. And then show that, assuming that it is true, it's going to lead to some contradiction. So that means my initial assumption was wrong. Okay? Now, I'm going to justify why line number 5 is invalid, which means you wouldn't compile. I'm going to justify that. Okay? Let's only do this one here quickly. Let's see very quickly to how to justify this. Okay, before I'm going to justify this, okay? So now, before I do that, let me just visualize these 3 lines quickly. Okay, I got S, which is pointing to some new students. Okay, I'll fill in the attribute in just a moment. Okay, and then Stella. Okay, and then I got also RS over here. So RS is assigned to some resident student. I'll say RS for short. Okay, and then also we got RS.set premium rates. So RS objects has some premium rates, and then 1.25. Okay, so now I want to prove to you why line number 5 should be invalid. Why? Okay, proof by contradiction. I'll start with that. First of all, assume RS is assigned to S, compiled. Assume. If it compiled, that means we can execute a line. What does the line do? Does that mean we're going to change where S is pointing to, or are we changing where RS is pointing to? RS, right? First, make sure that you're clear to that, right? Okay, basically what that would do is, so now executing, RS is assigned to S, redirect RS. In that case, I'll write it down over here. So that means RS is now going to point to a student's objects. So now we got aliasing. That means S and RS, they point to the same student objects. So far, so good? Okay. So now expectation is going to be very important. I want you to tell me the following. Okay, I'm going to continue into here, right? Okay. Continue from here. What's the expectation on RS specifically? Well, you got a diagram there. Okay, just tell me the expectation. When I say RS dot, what can I put? Well, first of all, let's do a review. We can say RS dot name, agree? We can say RS dot register courses, RS dot number of courses, and also all these. That's not a problem. Can we say RS dot premium rates? No. I'm only talking about can you, according to the table we figured out previously. We could, right? We can. Okay, first of all, RS dot premium rates. According to the previous table, we say that in order to see that, what's the static type for RS? Resident students. Agree? I'm only looking at declaration. Okay? And now, resident students, definitely you can call premium rates. Agree? That's from the compiler's point of view. Now, when we try to execute this, executing this at runtime, what will we get? Does a student object have any premium rates? No, because in the student objects, you only got name, registered courses, everything there, but no premium rate and no discount rate. So now, having this to be called over here is going to crash. So that's kind of the contradiction we are being led to. If we allowed the initial RS is assigned to S, assignment over here, if we allow it to be compiled, the consequence would be RS is now going to point to some objects which simply cannot fulfill its expectation. Premium rate. That's a problem. Guys, are you okay? Okay, we only got about a few minutes. I want to know you're comfortable with this. This is really important. So now, later on, what we will see is, we'll see some rule later. Whenever you have some variable v1 is assigned to v2, there is some certain rule you have to follow. Let me just mention the rule quickly. I will still go over that next time. The rule would be, let's say we got two different variables. The static type of v2, if you look at the declarations, is v2. The static type for v1 is this. What would be the rule to make sure, what would be the rule to make sure this particular assignment compiles? You want to make sure somehow this particular class over here is a descendant. You know what a descendant is? It's more like a general term than child classes. Of STV1. That's the rule. Very dry. However, it really comes from this particular proof, like an informal proof I'm trying to give to you. Okay? Before Wednesday, try to review this particular example specifically and see why it will be a contradiction. And make sure you're comfortable with the table we filled in together. Okay, I'll see you on Wednesday.